Alright. So, yeah, last night I was doing the Leetcode question of the day and I got stuck. So I caved in and I read the hints, which, is a bit disappointing, I guess. But yeah, I don't think, I mean, I may have solved it or not, but like, I did read the hints. I caved and I read the hints. So right now I'm just going to solve this question of the day. Cause like I'm pretty sure I got like in like an N4 solution, and like N is a pretty small number, just like 100. Oh wait, let me back up. So like what I'm trying to do, like, I left off last stream. Just I was looking at my submission. Actually, I shouldn't be doing that. It's a really slow submission, so it's pretty bad anyways. But like anyways, well the point is, this is random pick with weight, right? And like the whole point is to sample from policy, and like I think this will be a mini stream, a quick stream where I just only do that. Like if I look here, right? If I look here, get status, get pull, just make sure that nothing is nothing weird's happened. Okay, good. Then policy, right? Policy.ts, and then this thing right here. The whole point today, just because I have to go to Berkeley soon, is I just have to yeah, implement this. See this link? Random pick with a weight, right? And like that's this random pick with a weight. Like that's what is that's the plan. But I'm warming up with the question of the day I was doing last night. So basically, like this question of the day is the number of matrices that sum to target, right? So like here, like this is a matrix. Our target 0, like, same thing. All the targets. The target could be anything you want. It's 0, right? It's like 0, 0, 0, 0, 4, right? And this one, like 1, negative 1, negative 1, 1. This looks like a rotation matrix, but like the whole idea is that like row 1, row 2 sum to 0, and then column 1, which is 1, negative 1, and then column 2, negative 1, 1 sum to 0, and then the entire matrix sums to 0, so that's 5. The 2 columns, the 2 rows, and the whole thing itself. And this one, well, there's nothing. Only one entry, which is not our target, so it's 0. Right? We're really straightforward, right? So like what I was thinking is like, I mean, like I said, I was thinking it's dynamic programming, right? That's like my first instinct. Some like DP, like, you know, like the edit distance question, like kind of like that. Like you have like some cell top left or bottom right, and then you kind of look at the like I-1, J-1, or I+1, J+1 recurrence, something like that. I basically kind of like drew this out. Like I was thinking like, given this bottom right corner and like that's 0, 0, like we maintain like a prefix sum, which is like kind of like, but like 2D prefix sum. So like from here to here, we can like in constant time, just like in one iteration of everything, we kind of like do like a 2D prefix sum. So like ij means like all the entries from 0, 0 to ij, and therefore like if we kind of pin our top left corner, we can like compute d, whereas like the whole thing minus all of these three things. But the point is like these two things, like it's funny, like we get these cross terms. Like it's like we have to like kind of like pin this, or kind of like our lower, our bottom right. But then we have flexibility for top left, right? So we have like n squared. Let n be the side one. So it's like kind of n4, right? That's kind of like the issue, right? So I was looking, so then like I actually thought about this. I was like kind of like looking at the 1D case, because oftentimes when you see 2D questions, you kind of like a good principle is like, let's simplify the solution. Like if you start off with like a general problem, we can look at a toy example, like an edge case, a toy example, or like a simplified, like a simple input, like the 1D case. And I believe that's actually a Leetcode question too. It might be called 2-sum, I think, or something like that. No, it's not 2-sum. Well, 2-sum has hash set. This is hash table. But like the point is, like, what if we only had like our array is like 1 by k, right? So it's a single row. Then like, well, I mean, I wrote it out. Basically, it's just like we kind of like have like a DP, right? I mean, like kind of like we store like subproblems where like we just maintain like a, in the 1D case, again, like just like we had like 2D prefix, we have like a 1D prefix, right? Like the sum 0 to I, which is like the sum, and then like we like the whole complement thing. In fact, complements reminds me of like the whole like the policy, the flipping, right? Kind of like similar idea actually. Where like the target in that case with the number of columns -1 because it's a 0 indexing. Look how many times it's been found, right? So like the idea is that like if we have like I'm just gonna delete this line, but for now like let's just pretend that we have like kind of like target equals to 5, right? And let's say that like 0 dot 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 I, we know that like its prefix sum, I don't know why it's O, but R0 to I, like let's just say like that gives us like what, like 15, right? 15, like that's our sum from 0 to I. Like, just like our sum is 15, right? Then like say we found from 0 dot 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 to j equals 10, right? Then since 15 minus 10 is 5, that means that at this j, like that means that from j to I, wait no sorry, it's j plus 1 to I. From j plus 1 to I, we have found a sub array adding to target. That's it. Okay, yeah, that's the whole idea. And then again, like now that we did that, we add it to our answer, and then we like kind of store this. We increment our map for sum of I. So it's like DP, right? So that's it. And then the idea basically is to kind of like, if you look at the hint, which yes, I looked at the hint, it's already done, I might as well do it again, is it kind of like R2, R1, right? R1 or 2, like we kind of like take this, like we have like kind of like our matrix, right? Then we kind of lock in one row and the other row, right? We pin that, we kind of fix the height, and then we kind of like look at the sub array. So it's like, instead of like a single like sweep of left to right in like the 1D case, we're kind of like taking like a cursor, right? Like kind of like a blinking cursor, and we're just like a vertical line with a locked height, right? And then how many heights are there? I mean, just order n squared, right? You know, like you lock in one row and the other row, right? So you have like n choices for like the first row, n choices for the second row, but there's like a I is less than j, so we divide by 2, so it's like n squared over 2 possibilities, right? Like that's how many like heights that we can have, like how many places we can lock. We lock the vertical line, then we do the exact same approach. But I also said that like maybe lock in the calls because of like just the way like matrix, like the 2D arrays work. Like it's rows. The first index is kind of the row, and then the second index is a column in each row. So I think it'll be more clean if we do it this way. So yeah, let's begin. And also like one thing is like kind of in Leetcode questions, sometimes they got really good times. Like sometimes you can just like kind of, I mean, it's not good practice, but you can actually like kind of mutate the input given. So like it won't be a pure function. Like it will it's just kind of saving on memory. Like we could kind of like store like some prefix arrays, like new like do like a new memory allocation or whatever, but we can like just kind of like stomp the input, which I've noticed like many people do for fast results. Anyway, so let's begin. So rather than like locking the rows, I'm just gonna lock in C1, C2. And again, like let me take a step back. So I said I had an N4, like n to the 4 solution, which I didn't bother submitting. Like I have 0 submissions. So yeah, let's begin. This will be a warm up, and then once I do this, I will implement that. Like I have like the whiteboard, right? And I'll like kind of use this technique. But like my previous submission was actually done last year. And again, like it's a prefix sum. So like when I saw like today's like question of the day, last night, then I kind of realized it was prefix sum 2D. Then I'm like, yep, that's a perfect warm up for this question. Like lately I have not been doing Leetcode questions of days, because like a lot of them are easy, and like I don't really do easy questions. I just do medium and hard, and I've also been preoccupied. So yeah, so I'll just get started. So it's like kind of lock in like C1, C2, right? So like we're gonna like kind of like lock in like the columns. Like we're going to kind of like give it a matrix, we're going to like kind of like lock C1, and we're going to like lock C2, and then we're going to like treat this as the 1D case, right? Like the 1D case is like this, and like we kind of like go like that, whereas here we're kind of like doing it this way. So what we need is we need to like kind of like get these sums, right? Wait, no, what am I saying? That would be the row case. Sorry, that is terrible. No, we need to get like this sum here, right? Like we have like this sum, then we add this sum to it, and this sum, and that sum, and so on. So what we need to do is we need like a range, right? Like we need like given this and this. So how do we do that? Let's just like kind of start off by like kind of like each row we can like kind of build a prefix from it. So let's do that. Int or for int r equals 0, let's define m and n. Int m equals matrix dot length, and then int n equals matrix 0 dot length. That's like m by n is like a typical convention for matrices. No, well, I guess they didn't say it, but anyways. So then for wait, where am I? Yeah, here. So for int r, yeah, I have the Vib extension on. I mean, the Leetcode thing. So for int r equals 0, r is less than m. How many rows we have? R plus plus. So r's are kind of right now we're just building our prefix sums. That's it. Convert rows of the matrix into prefix sums, because like again, like what we want to support, we want to have the service where like given like some index c1 and some index c2, we can in constant time just look up our prefix and like do kind of like the sum of this minus the sum of that. Well, there's like a plus or minus 1, right? It's like whatever, like it's about equal to like this plus that, like, and then we kind of get that. So that's like the first thing, like we need to do this. That's why we're building our prefix sums. So we can in constant time get like for a given row, like in 2 indices specified, we can get the sum of all the elements in between, inclusive. Okay. Right, so let's do that. So we have the rows, and then like, so now for a given row, right? Let's have our int sum equal to the first entry in our row. Let's make sure that like, good. I'm glad that like there's no like zero nonsense. Everything is like m and n are both like they have at least something. So like we can safely say that the sum. Let's start off, or just we can say 0, whatever. Why not? So then for int c equals 0, kind of reminds me of like connect 4, like the r and the c, right? Like. This is very familiar stuff where like m is the game state dot height, and then n is the game state dot width, the num calls, and that's the num rows. Okay, so then c is less than n, c plus plus, not a c plus plus. All right, so then right, so then matrix of the row and the c equals to the sum. Well, we have to first cache the sum plus equals, we have to first increment the sum. What am I saying? So matrix RC, right? Does that look correct? Sum. So let's say it's C is 0. Then we kind of do itself. So the sum now equals the first entry. And then that's a no-op. We could just do c equals 1 and start off the sum as matrix of r comma 0. That's a possibility, but whatever, this is simpler. Okay, and then when c equals 2, then the sum after this line, after line 9, the sum would be the sum of the first 2 elements, r and then 0 plus r and then 1, and then we do it, and all the way to the end. Perfect. So that, and we do that for all the rows. So convert the rows and prefix sums. That's good. But let me just, yeah, no, okay, now, let's have a helper method, right? Private helper, yeah, just helper. I mean, and we can, I mean, this is not making me comfortable, but let's just do it. Int answer, yeah, int sum equals, or int answer equals to 0. Actually, I'll make it sum. I mean, I was looking at this sum and that sum, but this is local and that's global. Wait, actually, no, there'll be a conflict. Yeah, int ans equals 0. At the end, we're just gonna return answer. Return ans answer. Answer is like kind of like the global sum. Okay, so now what we're gonna do is like again, like kind of like you had like R1, R2, right? But we're just kind of like we're locking in C1, C2 for all the possibilities, like about the n squared over 2 possibilities. So int C1 equals to 0, C1 is less than n, and C1 plus plus, and kind of like copy Okay, so now we have wait, no, what am I doing? Sorry, C1. So C2 equals to C1, right? Is it equals or greater than? No, it can be equals. It can be equals. They can, if they both are the same, then that's just like, that just becomes the 1D case, right? So this takes care of all the pairs, does it not? C1 0, C1 less than n, C1 plus plus, C2 is C1, C2 is is less than n, and then C2 plus plus. Okay, fine. So that locks our two columns. And what we want to do is we want to call helper on int C1 int C2. So that specifies our range. And then what? We need the matrix, right? We need the matrix, and the matrix is already like the prefixified, or like the 2D prefixed sum of it. Matrix. And that is it. Well, let's not give it a comment. We all know what it does. Actually, there's no need for me to actually put the helper. I can actually, let's just delete that. We can just do it. We can just like do it in there, right? Let's just do it. Let's just write everything inside here. So let's first give us some let's give us some space to work with. Okay. So now what? We have C1 and C2, right? So we have C1 and C2. Then, have we used the variable I yet? No, we haven't. So now for int I equals to, right, so like we're kind of like going down, like I is like, so we start off at, we start off at, wait, if it were, we just took it from 0 to the end, right? Yeah, we locked it this way, so we have to go from 0 to the end. So for I guess we could call this R again, right? Kind of like that. Let's just yank line 7. For int R equals 0. Okay, so then for int R equals 0, and then we need to store a map, right? Hash map of the integer, and that is sum to count equals to new hash map. Perfect. Again, like I mentioned, like this whole thing right here. I deleted it, but like yeah, we just kind of store that, and we store the map. The key is a prefix sum, and then the value is the count, right? Have we used sum again? No, the sum was local to the for loop, so we can have a new sum. And sum equals 0, right? Oh, how long did I start? Well, I mean, whatever. Yeah, I don't think I would have solved this in time, to be honest, unless the interviewer gave me a hint. But I would have solved the 1D case easily. Actually, technically I'm solving the 1D case right now, right? So then for int R equals 0, right? And then for R is less than M, R plus plus. So now like we have like, let's say we have like this much done. And now we're kind of like looking at like this next one. Like that's kind of like what's in progress. Like this row right here, which I tried to do that, did dashed diagonals. So like we have this row, so now we need to like kind of know it's sum. It's a delta sum. Int delta sum equals to, and this is like the range, right? Like given this row, like we want to, like given the row, we were trying to find like this thing right here for the rth row. So that is the matrix of the row R, right? Of the C2 minus something like this of C1. No, this is like, okay, fine. Let's just say that, and I think I'm missing a term, right? Or like something is off. Like if you have like, let's say like this, like here, 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 and you want to like get this, like this term right here, like 0, 1, 2, 3, then like that would be the first one, and you want to subtract this one, but I'm subtracting this one here. And then the 0th case, like it's kind of like you have to like kind of like do this minus this one minus 1. But what if it's 0? So then like I remember there's a technique which I kind of like use sometimes. Is like we take this sum right here from like 0 to 3 inclusive, and then we take that sum there, we subtract it, and then we kind of like add this one. Oh, but we deleted it. Oops. We stomped it over. Yeah, well then. The only issue with this is when C1 is 0, then that's -1, right? So minus equals to C1 is greater than equals to 0. Sorry, C1 minus 1. Wait, what was it trying to do? That, right? Now the issue with this is when C1 equals 0, right? Okay, let's do that. So C1, wait, C1 is C1 minus 1 is greater than or equal to 0, then obviously like this thing is greater than or equal to 0, so that works. Or else it is just the first term, is it not? C1 minus 1. Let's just C1 minus 1. I don't like this equal sign. Let's just delete that. So like kind of C1 minus 1 is greater than or equal to 0, which is the same as C1 is, why can't I do simple math? C1 is greater than or equal to 1. So C1 is greater, or which is the same as C1 is greater than 0, right? So C1 is greater than 0. Yeah, so the only issue is when it's 0. When C1 is 0, then like this whole term becomes -1. Or else it's just the first term. Yeah, exactly. Stupid edge cases. So that's delta sum, right? So then, so that's our delta sum, right? From all the way from like 0 to R. Like that's like kind of like this partial sum here, like it's like all of this right here. That is our, that's what we have so far. And then like we have to kind of like look at like anything previous, right? So like, okay. So we have the sum, and then like int target complement equals to so like is like delta sum minus target wait, what, minus target, right? Target is here, yeah, target, not target, it's the store target. So target complement, so like we have delta sum, and then we look at the complement, right? And then like if that isn't sum to count, then like, yeah, so like if the sum to count dot contains key target, whatever. Let me just yank that. So sum to count contains key target complement. That means that like we've found this before, right? That means that our answer, we can now increment our global answer by sum to count dot get. Wait, we can just use get or default. What am I doing? That's pretty stupid of me. Get or default. Yeah, let's just delete that. Delete that. And we just default to 0. So that's more clean. And then the key is the target complement. Yeah, autocomplete. I was looking for that. Okay, that is it, right? Oh no, we have to increment it too. So then once we're done with that, then like sum dot what is it called? Put if or put or wait. Sum dot put, yeah, and then again sum dot default. Sum, and we have to increment by 1. So we have to put wait, what am I saying? Sum, not sum to count. For future iterations, obviously. We have to also our sum is actually not being changed. We have to actually do that. So once we've found our delta sum, then sum plus equals to delta sum. So now that's our new sum. And then what we do is kind of like what we're doing there. We just kind of like do that. Sum plus, I mean, okay, technically what I can do, instead of calling it, well, never mind. Yeah, so this is not delta sum, this is just sum equals target. In fact, let's just take this whole thing for delta sum and just kind of copy it, because we're only using a variable once, right? Like, why are we using it there? That was just stupid, right? So let's just delete all this and just kind of put its contents in here. So then target complement, and then we do that, and then we have to increment the sum, because like we have to like increment the count of the sum to like something, like the getter default plus 1 at the end, and we're done, right? So that is like kind of like the same idea right here, right? And that would be for sum, right? Whatever like this thing here is, it's itself. I have to plug in. Oh wait, my Apple Watch is. I only have one adapter. I have to plug in my MacBook. Don't want it to die on me. Oh, I have some breakfast to finish. Let me just quickly eat that. All right. So yeah, I think that's it. Am I done? So we locked the columns. And then we kind of got that. We got like this range right here. We kind of did it. We like checked how many we've seen previously. And like we've seen it twice, then that means that like if it's not like there and there, then that means that we kind of add it twice. That means like we have like this is an answer and that is an answer. Right? So like we've found like 2 answers, so we do that, and then we kind of like add our sum to the hash map, increment it for future iterations, and that should be, I mean, everything checks out to me. Do I just submit? Or let's just run the test cases. Wrong answer, 2, 4, 1, 5, 0, 0. Well, of course I get 0, 0, but what am I doing wrong? What? It's 2, 4, 1, 5. Okay, this is really bad. Okay, C1, C2. This looks good. I don't see what's wrong with this. Okay, let's put a breakpoint here to make sure that like everything is kind of like, so like let's just make sure that like this would be 0, 1, 1, 1, 2, 3, 0, 1, 1. Make sure that like that. I just want to step through it and see what happens. Debug. 0, 1, 1, correct. 1, 2, 3, correct. 0, 1, 1, correct. Okay. This is the very first column. So this should be 0, hopefully. Sum is still 0. Target complement is 0. Oh. Okay. You have to put a dummy answer for 0. Target complement, comma 0. I think that's an edge case. So target complement is 0. Like, do you have to like initially like say that there is like 0, like to initially put a dummy entry in sum to count? Like, let's say, okay, so like let's say that we like see the very first number, like we just kind of like get something, and if that is already the target, then yeah. No. So like, so yeah, okay. So like, if the target, like, if the sum is already equal to target, then we're done. Like, I think what I think is like, come on, 1. Because like, let's say that like the sum for 0 happens like k times, right? Then like, what we want to increment is not k, but k plus 1, which is why we need this. And why k plus 1? Because like, that's kind of like an edge case, because like we found like k already, but then it's the whole thing itself, like if it equals the sum. Like what we could also do actually, what another way for rephrasing this, I think, is either this, or what we could do is we could say if target complement equals to 0, that means that like the sum is the target, then answer plus plus, like something like that. Like we could also do that. That's another way of doing it. So yeah, let's just try running these. Nice edge case to trip me up. Okay, submit. Yeah, I spent way too long on this problem. I only beat 58.63%. Oh well, I mean, I'll take it. I'll take it. Let me go back to my thing, see the notification. Plus 10 a few seconds ago. Nice. Just refresh. I want to see like the red dot, like the notification bell. What? Sometimes like they have a whatever. Anyways, yay, and like I need like a 1 point something K for a free Leetcode t-shirt, I think. Or, anyway, so now back to this. So the whole point today is to just kind of like implement our sample move. Like that's very unambitious, I know. I'm sure I can import some libraries and from npm that do this for me, but like I just want to do it myself. Just kind of like, it's like the whole principle of my game, and like everything is to kind of like do what I want, like do stuff by hand, whatever's like within my abilities and like is practical. And this is not too impractical, it's good practice anyways. So basically, like when so the whole point, taking steps back, is given policy, like some kind of like a bunch of moves and probabilities. Like we want to choose the move, like and sample it, like with respect to the weights, where the probs are the weights. And again, I already mentioned this yesterday. I was talking about like, yeah, we can actually erase everything. I think we can select stuff too, like kind of select everything. Or wait, no. Select, delete, select. No, I don't want to delete that. I just want to delete this stuff. Exactly. So like right here, this is like the whole idea, right? So like if I look at my submissions, I already solved this question, but I perform really poorly, right? Like, what's my solution? I built up a prefix sum, and then start 0. Get random number between 0 to sum minus 1. No, this is dumb. I mean, this is not what I want to do. I said I want to make the random number between 0 and 1. Oh, do the props add up to 1? I forgot. Do the weights add up to 1? Oh no, they don't. Okay, first thing I'm going to do, which may not be optimal, is I'm going to convert these weights into, I'm going to first normalize the input. The reason I'm going to do that is so that I can, I just want to transform this into this. That's like my idea. So like this may not be optimal. Of course it'll beat, hopefully, 28 or whatever percent. What percent was that? It can beat 40 milliseconds, 24%. But like, you know. Okay, so let's first normalize. Sum equals 0 for intelligent code complete connection failed. I don't know, let's refresh it. For int num in w, just standard stuff, sum plus equal to n. Normalize w. Oh, but then divide by 0 error. Okay, so the weight are at least 1. So like it's not gonna be any 0 error, so that's good. Then sorry, but wait, what? Just normalizing it. Wait, that's not an operation? Okay, it is an operation. Great. Okay, so now we have to pick an index, right? So let's do it like, let's do this technique. We first pick 0 to 1. How do I do that here? My submissions. We don't want ends. Was method random return? Double. Turn -1 just to make this red line go away. So we have our double, which is random between 0 and 1. Okay, great. So so then what do we do? Between 0 and 1, and then we just let's just go left to right, right? Like kind of like build up this, right? So like oops. We do and sum equals to 0, for int I equals 0, I is less than w.length, I plus plus. So we're testing to see if what do we want to return? The index. Okay, yeah. So we're testing to like see like all the i's. So each I will be like which index, like 0, 1, 2, 3, like, or I guess 1, let's pretend it's 1 index, like 1, 2, 3, 4, like I would be like the bucket we're currently testing. Let's just like, let's just make it all zeros. Zero, 1, 0 indexed. All 0, I mean 0 indexed. That'd be 0, 1, 2, 3. Okay, so for I equals 0, like we have to compute like this 0.4, right? So we just like do the sum. Like we first do a sum plus equals to standard prefix stuff, equals to w of I, right? Now then, like this thing is let's say that we get like 0.8. Let's say that we land here, right? Then like, I think like a while loop is more appropriate. We just kind of skip and skip, right? Like, while that's true or trunk. Yeah, let's skip this for loop nonsense. I mean, I know for loops and while loops are equivalent. While rand is greater than the sum, while I so while I is less than that, like if it's just like 0.8, like while we skip that, 0.4, 0.7, let's say that's in here. Sum plus the weight. So if we land here, then we don't want to enter the while, right? So it's like sum plus the weight. I think that, yeah, that's how you do it. Sum plus W of I. And then sum equals to actually let's just be yeah, whatever. I could do plus equals, but this will suffice. And then I has to be less than that. So while I is that, and then the random is greater than or equals to, wait, does it have to be greater than or greater than equals to? While the random, yeah, it could be equals to. Like if we were to return 0.4 exactly, we'd return 1 because it's like inclusive, but the end is exclusive, like that. So if it were like 0.8, we'd skip here, then skip here, and then we cannot skip here. Now let's say that it's a 0.3999. It's not 0.4. Let's say it's 0.3. Then what would happen? Then this would not hold true anymore. So then we'd like kind of break out of it, and then I would remain that. And what if like the probabilities don't add up? Like, but by dividing, like what if like inside same here? What are the probabilities like kind of add up? So I think I mentioned this concern. What if the probabilities add up to like 0.998 or something? But then random gives you 0.999. Like what if like we fall outside the bucket? Like what if like our random choice is here, but like instead of 1, this ends up being like 0.988 or 998 or something. Then like that's kind of like why like we'd have to like kind of return like we have to kind of like max it out, right? Math.min of like I, and then like if I is too great, then like the largest I possible, which is w.length minus 1. Like what if we overshot it? Like what if we reached the end and like we kept skipping over it? Just like a nice math.min just to be super safe. Oh yeah, int I equals, we have to make we have to define I first. What is the problem? Something like this. Sum. So let's say that it is a 0.4 exactly. Then 0.4 is so I is 0, and then let's say the random is 0.4 is greater than or equal to 0.4. So that just holds true. Then I plus here, I plus. Then sum. So now our new sum is I plus. Okay, so now our sum is 0.4, and then our new candidate is this bucket, candidate 1. But then that does not hold true, so then we just return 1. Okay, now let's pretend that like it is let's say that our random number gives you a 0.8, like this arrow sign right here. Then first when it is when I is 0, the first bucket, then sum is like it'll be 0.4. And then 0.8 is greater than 0.4. Great. So now our sum is 0.4. We test to next candidate bucket, which is 1. And then what we do is like we look at, yep, so I is 1. That this is fine. It's within the length. And our random number is 0.8. And it is greater than sum, where our sum is 0.4. And then this W of I, W of 1 is now 0.3. So this test, the right hand side would be 0.7, and 0.8 is greater than or equal to 0.7. So we again like kind of set that and we advance. So now our candidate is bucket 2, the third bucket, and then we want to return 2. I know that. So like what do we do? Like 2, like good 2 is fine, and then the 0.8, is it greater than or equal to 0.7 plus 0.2, which is 0.9? No, it is not. So this holds false. We don't increment, and we're stuck with the candidate I. And again, like I'm sticking this min just in case like we end up like hitting it again and like we kind of go off by 1 just to like kind of correct it. So I think this looks good. Let's run it. 3 milliseconds. Okay. Submit. Wrong answer. Oh, sum has to be a double. Oops, what am I doing? Double. Yeah, let's use this test case. That's a shame. Now my submission history has a wrong answer for this question. It's quite embarrassing. Okay, today I'm really off, actually. Well, no, that zero edge case was a bit tricky, I must admit that. I think it got me in the 1D case, because that was definitely a Leetcode question. Okay, now let's run it. Making that double. Please pass. Wrong answer still. Oh, it should be a double array. Yeah, integers truncate. I mean, we need a double. Let's just call this I don't know, U for unnormalized. So then for int that plus W of I equals to U of I divided by the sum. Something like that. U of I divided by the sum. No, sum we must make double. Any casting errors? Well, let's see. Nice, this passes. This dot, why is there a squiggly line there? Let's delete those. Oh yeah, this is pretty dumb. We already have it right there. Double. Run it. And submit. Oh, this only beats 5% of people. It got much slower. It got way slower. I guess because I did the whole normalization thing, maybe, like, I kind of, like, had to normalize it. Ouch. Okay, let's see what the editorial is, like. Machine learning. Oh, wow, that's really helpful. What, only 3.8 stars? Okay. Yeah, sample a batch of data. Exactly, feed them into a model. I mean, the whole point is to sample. I mean, well, no, this is actually stochastic gradient descent. Like, or I think this is something else. Well, never mind. Like the S and SGD. Or wait, is it? Never mind. Let's not worry about that. Prefix sums. Linear search. Are they going to do binary search? I mean, the thing is, to generate the prefix sum, it's still ON. Like, that cannot be, like, changed. Yeah, it's ON, the prefix sums. I mean, to be honest, I prefer this method because we're not actually, like, in fact, I feel like my method, in fact, is actually more elegant. Like this whole pick index, we're actually not doing any prefix sums here. That was my whole idea. I thought that this would be faster. Well, I forgot about that, but like the whole premise of this is like this thing can terminate, like this in particular, this condition right here, if the rand is strictly less than our new kind of test endpoint. Test endpoints are these underlined, then we just kind of can quickly terminate, right? Like, let's just say that our random number generator returns like 0.1, then we kind of like already know that like we kind of like use this entry right here, 0. Like we don't have to actually like kind of like test it again, like build the whole prefix again. Wait, no, I am an idiot. Sorry, no, it does make sense. It makes a lot of sense to build this prefix sum. It makes a lot of sense to build prefix sum because like we're not calling this just once. Like we're calling this like many times. Like that's how like it's testing it. It tests it by like repeatedly calling it to like get a distribution, like law of large numbers stuff. Like it calls it a lot, right? Like that's what it does. It calls it a whole bunch of times. That's why like every single time, like each time we're doing pick index, we're repeatedly like kind of doing this, like this whole thing. We're kind of like building the prefix sum again and again and again and again. Like all these kind of like additions like are keep getting done over and over again. Like whereas like we can just use pick index, like we can just use a prefix sum and like we can just like kind of like have the prefix sum built in everything for us. Now the question is like, given a policy in my game, right? Because I thought I was being fancy here because like we're just kind of building a left to right, but we can early truncate. But I think in my game, this how do I get rid of that? Yeah, I hate this new dynamic layout. In fact, I just like today morning, like Leetcode, like when I looked it up, I logged in, like it gave me like a like like those little like things like that pop up like off in the bottom right of your web page, like kind of like asking you about like giving some survey feedback. Because like if you look here, like the new dynamic layout editor thingy, like this Leetcode interface change, like if you see here in like where I'm kind of hovering my mouse, this 1.7k like count in like the bottom left corner of the screen, like they show the like count, but they don't show the dislike count. So I really hate that because like I only look at like things that have like a good ratio. Boom. There we go. So now you can see it, right? It's like kind of like the like's still 1.7, but like the dislike is like, it's like 0.7k dislike and 1.7k. So it's like greater than 2, like 1.4, like it's like around like 2 point something like the dislike ratio. So that's good. It's greater than 1 at least. But like, anyways, the point is that like pick index, like it might make sense to build up a prefix array in the constructor itself so that like in subsequent calls of pick index, we would like we can like leverage the fact that we've pre-computed our prefix sum in the constructor. So like all subsequent calls can be done really fast, like binary search can be done really fast. So like that's a kind of a neat idea, doing binary search here, right? Because like we have like no probability, all probabilities are non-negative, strictly increasing things. So it's like a prefix sum's a sorted array, and whenever you see the word sorted list, you can kind of instinctively like binary search should pop up. So yeah, I mean, but I do think that like this method is nice because it truncates like it truncates yeah, it just kind of it can fail fast. Like the moment we find the bucket, we don't have to like do all the other prefix sums. We can just bam return that bucket itself that we stopped at, right? This while loop skips past all the bad buckets, all the extra early ones, and like lands us where we need to be, and we don't continue. And then the thing is, if I actually like look at the Monte Carlo tree search, right? Like I don't think that like I think that like it's okay to do it this way, right? Like you see like we're sampling the action for the improved policy. Like we're not calling this like 10,000 times or like however many like they're doing here, like at most 10 to the 4, which is yeah, like 10 to the 3 is 1,000, so 10,000 times. Like we're only calling it once. Right, like the only time we're only sampling like per move. Like all the computational work is done in these two lines right here, actually in like doing the Monte Carlo tree searches to get our improved policy. And once we have the improved policy, we only use it exactly once. Well, technically we're putting it into examples. That's like a kind of a background use, but we're only using in the gameplay to sample it once for the improved policy. That's it. So what I need to do now is I'm satisfied with this thing right here. Like the constructor just normalized it, but like Remember that softmax, like the softmax function, the neural network already normalizes it for us. It all sum to 1. So we can just copy this code, right? Into like this right here, we have to just copy it, right? Int or double or just like rand, like let rand, which is the number, equals to math.random. Actually, wait, where is that thing? I have like the commit, right? Like where I have a random somewhere. Oh wait, no, it was there, right? Was it there? Search random. Yeah, math.random. Just math.random is copy that. Gives me between 0 and 1. So rand is like our 0 to 1 random number. And then what? Double. So let sum equal 0. Let sum number. Again, number in Java is 64-bit double, so it's like the same as saying double. I mean, I don't know. I don't really know JavaScript that well, to be honest. Let I, like, there's no integer type. Let I number equals to 0. Copy that, or wait. So i's are kind of like our index, but I is not the column index. I is just a pointer to the move. I is just like our index in this, right? So while I is less than this thing right here, while I is less than dot.length. So like while we're kind of pointing in that, or is it dot length? Yeah, I think so. Dot length and rand is greater than or equal to sum plus, and then wi is the probability of the ith move, right? So that can be written as this thing. Well, I need some white space. So move probabilities, we have to get the ith move and probability pair, right? Like WFI, and then we have to do 1 because like move and probability gets you like the pair move common number, and the number, the 1th, like the 0th and the 1th, the number is the prob. So that's that. The sum plus or equals, like, it's WFI. Like, this whole thing right here is the equivalent of just WFI in the Leetcode question, right? So then we just close that bracket there. That closes the while loop. And then what do? We do some increment stuff. Let's see. We increment, we increment that. So sum equals to, just kind of yank this thing right here. Again, I'm not using plus equals, so I want to leverage the copy and paste feature. And I++. And that's it, right? And then what we do, let's just do, I equals to math.min of, I, and then that thing right here. The length minus 1. That length minus 1, and then what we do is we return, like, I, again, is just a number, it's a pointer, right? So we have to do that, right? Moves and probably have to get the ith element of that thing. Like in here, here Leetcode, our only thing is to randomly pick the index, that's it, right? Like this array, like the arrays that like they pass into the constructor, like implicitly have like the moves, like all the entries have both the entry itself and the index it's in. And the index is like the move. But here, we actually need to index into it and get the move. So we paste that and we get the ith thing, and that's like the thing. And you have to get the 0 thing, the move from it. Should I do move? I could do a move.clone actually on this, but I think that's sufficient. Okay, I think that's correct. Let's just make sure it compiles. Nope, it does not. Yep, I forgot the this. Typical me, right? So let's just kind of like copy it, because I'm just feeling yanked up there, and then okay, that looks good, right? So let's just see what this does. So random takes random between 0 and 1, and then sum kind of builds up our endpoints. And then I is just like our index to iterate to aid us with our iteration. And then again, I++ is crucial, no infinite loop nonsense. So while I is less than the length, because again, like we want to make sure that I is valid. Like we don't want to overshoot and then like have this give us like an out of bounds exception. I'm speaking like Java terms, but some error, I'm sure. So then while we're in the proper range, and then the random, and then we extend it to like this ith bucket, right? So like we take the probability that we have all the previous ones, and we add our own like prob to it, like what we're doing like right here. We're just extending it. Like we're kind of like all these underlined like probabilities, like the endpoints in these buckets, these ranges. We're building up our new endpoint. We're testing, and if we can skip over it, if it's greater than, that means that it's not in the ith bucket. So we kind of do some bookkeeping to increment our endpoint. Like we're just kind of extending that, and we're passing to the next bucket. We keep doing that until like if we overshoot, then we kind of min it and we kind of go back to the end. I hope that this would like, I don't think that would ever kind of, the point is, I do think that like we'd kind of like terminate in the last bucket, but in case we don't, like just the probabilities don't, because again, like doubles, like floating point operations, 64-bit, like you cannot precisely represent like some decimals. Like if we do like 1 divided by 9, it's like 0.11111 infinite. At some point you have to truncate. So like certain fractions, certain like rational numbers, like certain fractions cannot be like, you know, like integers, like in the range like 2 to the like whatever, like negative 32 to like 2 to the 32 minus 1 can be precisely represented, right, in like 64 bits, but like floating points might not. Anyways, the point is, so we got the I, and then we could just return like the I, then we could return the move that like the I points to. That should be good. Okay, let's commit. Let's test this. Oh, oops, sorry, not that. TSC, make sure everything compiles. Good. Get status, clear, get diff. So now like we implemented this function sample move, and I think that's a good point to stop for now, because I mean all this Leetcode stuff is kind of tired me for a bit. So get status. Oh yeah, get add. Status. Get diff staged. Staged. Yep. Okay. Yeah. Status clear. Get log. Get commit. Implement sampling a move from a implement sampling move from policy. Implement sampling move from policy. Status. Get push. Not a lot of work done today, but like just enough to say I did something, you know, just little incremental progress, step by step, get it all finished. Commits. Implement sampling move from policy. I could have like capitalized the M because I capitalized the P. Like they're both like kind of like our kind of official types. Oh well. Yep, sample move. You just do all the stuff I did there, and that's it. Yep, that looks good. I think I'll just end it here. Status, clear, get pull, get log, implement sampling move from policy. All right, that's all for now.